guys, welcome to another episode of Sound Talk Show. Today we are going to code Emacs Lisp. We are going to write a program that validate brackets. Okay, so here's my keyboard. Glove 80, fantastic. Ultimate Hacking Keyboard, fantastic. Nulia trackball, fantastic. And here is the Logitech G502 with a spin wheel. The spin wheel is fantastic. But now my main is the trackball. Okay, so that's my keyboards, and there's also this Svalbard data hand, SVALBOARD. I will be using it down the road. Okay, you can search for my reviews and other people's information. SVALBOARD. This is a fancy advanced keyboard. If you have, hand pen, or if you want, reduce typing discomfort, things like that. Okay, but now let's code Emacs Lisp. We started to do it yesterday, but or 2 days ago in my live stream, we started to talk about politics instead. So today we are just going to code Emacs Lisp. If you are watching this offline, not live, you can skip around because I talk slowly. Okay, so it's gonna be probably 40 minutes to 1 hour. So let's code. So we did this about 3 years ago. Let me pop out the chat. Okay, am I alive? And let's see. Wait, am I concurrent viewers 0? Fantastic. Okay, but I think I'm going. Okay, yeah, live. So we did this about 3 years ago, and we just gonna redo it. We did this live stream 3 years ago. So if you are impatient, you can just go to my website. There is the Emacs Lisp code, the problem specification. You want to, give a file like that. Let's see if you can see it. Yeah. So given a file, you have a lot of nested bracket. The bracket can include square bracket or round bracket or Unicode or curly bracket or curly, or in America it's called braces. Okay, but you can also have like corner brackets. This is used in Chinese and Japanese, or you can have turtle brackets like that. So, but you don't want mismatch. So if you are missing one, that's bad. So we are going to write a command that will tell you if the file is missing one bracket or if they are mismatched. For example, right now this right paren is mismatched. You see, you see, so if you move this one inside, then it's correctly matched. So we are going to write a program to do that. That's what we're gonna do today. So if you are impatient, you can just go to my website already. There's a Emacs Lisp problem specification, and we already have a code solution. So this is Emacs Lisp with explanations. So code explanation. You can read it and you can write it yourself. You don't have to watch the live stream. But however, you see, this program is written as a script. That is, you copy the script. Let me show you. Okay, so let's press a key and delete that. On the pink window on the left is all my Emacs command calls and keystrokes. For example, I press this key, it calls the command smart delete, and the keystroke is E on the left. I'm using a Vorak keyboard layout. So E on Vorak is the QWERTY D. So on your keyboard is a D key. There's no control, there's no meta, there's no alt key, because I'm using XAFly keys. So I'm using XAFly keys, which is an efficient Emacs key binding. You can search it, you'll find it. It's free. On GNU's repo, and I'm using Vora keyboard. Okay, so let's undo. So you can see this section is back. Showing browser, that's this section. So for example, cancel the selection. I press one key again, go to the browser, refresh, you see that whole section is deleted. So this is a combination of XAFly keys. The command name is XA Smart Delete, and I'm also using XA HTML mod. So if you pay me, buy my XA HTML mod, it's open source, you get the source code, then you can have that. Otherwise, you can have XAFly keys. Okay, that's a pink window showing all my commands. It's useful because sometimes you don't know what I'm doing. You can look over there and you can use most of the command. I also have the source code on my website, so you can go there and grab it. For example, this smart delete, if your cursor is here, if there's empty lines, white spaces, you press one single key, it will remove all those white spaces. And now when there is a section in HTML, you press it again, it deletes the whole section. Or, for example, undo, let's put a cursor here, you press one key, that whole unordered list is gone. Undo. You see, or you move the cursor here, you press one key, that whole item of the list is gone. Undo. Or if you have a paren or bracket in, let's say something, you call smart delete, one key, you see that whole parenthesized text is gone. So this is, some of the power of the XAFly keys. You might want to try it. Okay. Okay, let me show you quickly the source code then. So there is the website. I talked about it often in my live stream. So you can see here is the XAFly keys, and here's a video tutorial how to install and so on. Here is how to download on GitHub and so on. Or you can get it from non-GNU Alpha. Okay, that's XAFly keys, efficient key binding, and basically you got this, so each key is a command. It's more efficient than VI, Vim, NeoVim, or EvoMod. Okay, it's more efficient because less keystrokes to do the same thing. Okay, that's XAFly keys. Now let's go back to talk about what we want to do today. So this, we have written this. Let me show you the code brief. So go to my Emacs init, or these are my Emacs init, search for validate. So there it is, validate bracket. So this script currently, it is written as a script. So what does that mean? That means you go to terminal. For example, I am on Windows, so I go to PowerShell, and you just run Emacs, let's magnify, I believe, then script or batch. Yes, I think there's a new option. You just say script, then you just say XA validate. You see it, you run that like the way you run Python or any shell command. Then you have to give a file or directory. So anyway, so that is the form of the script as it stands right now. But you see, but we are going to make it into a Emacs command. So in order to run this, if I want to check this file has, have whether it has mismatched bracket, I don't have to go to shell and, then which file name I have to check. I can just metax call the command in Emacs and it'll just check the current buffer. So that's what we're gonna write. Turn it into a command. So once you have command, let me show you. Okay, so once you have command, let's say defun, let's set this to XA Emacs Lisp mod. Okay, D for defun. So once you have the command, then you can turn it into a script easily. For example, you just here, suppose here you define the command, it's simply a single function. Then over here you just call it. Then you call it, here is the argument from the shell. I have a tutorial on how to do that. You just Emacs tutorial, search for shell arguments. So let's search for argument. Get command line arguments. You see, so this is how you get the input from the shell, and you can pass it to your function. So you just run Emacs script, my script name, and argument 1, 2. The argument may be parentheses, maybe file name, like, because there are so many different type of parentheses. Maybe you just want to check, the round parentheses, whether they mismatch or not. You don't care about other type of parentheses. So anyway, so this is a page that tells you how to get the arguments from the shell command line. It can be a PowerShell, it can be E shell, or it can be Bash, and so on. Or on the Mac, Z shell. So once you have a command, you can easily turn it to a script by just call the argument, get the argument. So then you save this file, and it becomes a script. So you can run it in terminal, or you can run it as a command in Emacs. Fantastic. Hello WZN. Hello Subhadget. Mishra, can we see your commands? The pink window, please. Thank you. Can't you see it? There it is. What do you mean, can you see the commands? So I don't know what you mean. So the pink window is right here. You already see it. Okay, now let's work on this. Okay. So I'm going to write a command. So so create a new. Let's do that. Okay, create a new file. Save it. Let's name it validate brackets.el. Okay, so let's just say, give it the temp name. Okay, so define a function, documentation, validate brackets of current buffer. Let's just say that. Okay, let's say we just focus on the current buffer, because once this command works, then you can call, you can have a Emacs work directory command. Let me show you. Okay. Let's go to talk show. Let's go back to talk show. Paste the link. Close that. Talk show. Today's talk show. Show in browser. Go back here. And what is that? Yeah, Golang. By the way, I also have a version in Golang. Fantastic. Okay, but anyway, let's post the link here. What I want to do now. So close that and go back here. Yeah, so this is original. We're gonna code it fresh, so you actually know entirely what I'm doing. So first of all, give a name. Validate brackets. Okay. Yep, that's validate brackets of current buffer. So once once this command is done, then you can create dates, version date, for documentation purpose. Once you're done, you can just call, let's go to Emacs Lisp. So Emacs Lisp, so you can, there's a how to traverse a directory. There it is. So you just call this function and pass this function, so it can go through all the files in a directory. I have like 10,000 HTML files. But the heart of the problem is to call this command on the current buffer. Okay, so validate brackets of current buffer, and okay, so we can start to write it. So let's create a new window. Let me so create a new window. Let's go back to the previous. So okay, so we got a lot to code. It will be 40 minutes. How's it going, everyone? Okay. I'm drinking watermelon juice. Fantastic. Okay, so concentrate. So, okay, so we want to validate the current buffer. Okay, so the current buffer. Okay, so basically the algorithm is that you want to check nested brackets. Now let's forget about all these different type of brackets. Okay, let me show you. Let me just go slowly. So if you are watching this offline, just skip around. So we got the work directory, then we got, yeah, let me show you the Unicode brackets. I talked about this quite often, but it's been a while, so let me show you again. So in Unicode today, you have lots of type of brackets. So, and brackets are very useful because they are the unique characters such that they are paired. So once your cursor is at one pair, you immediately know without doing any sort of parsing. You know where is the end position. So, that's what bracket pairs mean. There's a beginning position, there's an end position. Okay, so for programming languages, using brackets is a great choice instead of using begin and end like the Ruby idiots and Bash idiots. Begin end. Don't use those keywords because okay, over here. So you can see there's your well-known brackets, paren, square brackets, curly brackets, or braces, paren brackets, braces, or in United Kingdom they call it round brackets, square brackets, curly brackets, more logical name. But then you also have curly quotes, single quote, double quote. Then you have like weird quote used in Romania or other countries. Then you have the French quote, the guillemette, sometimes it's called, or angle quotes. Then you have white variants of the paren brackets braces. Then you have small variants. You have double variants. Then you have Asian variants. So very useful, extremely useful when you design a programming language, for example. And in fact, it's used in some of the languages. For example, Fortress, designed by the scheme guy, what's his name? And also in Wolfram language, but actually they don't use the characters directly. But so here's a Wolfram language, fantastic. I did this, a few weeks ago about these curves. And anyway, so let's go back. Let's get this done, okay? So yeah, highlight brackets. So these are all different type of Unicode brackets. There's also vertical versions and there's decorative brackets. Also, these are very common, okay? Decorative brackets, quote and quotes. And there's other exotic ones, typically you've never seen this before. And in Arabic language, you have this, and also in Tibetan language, you have these, those are brackets, and whatever this language is, Ogham. Hello, empty grocery bag. Fantastic. Okay, so we got the brackets. So yeah, close that, copy the link back to Emacs, close that, paste it, make a link, and make a list showing browser. There it is, the most efficient way possible. Soft-like keys, okay? Of course, you also got the keyboard and some markers, certain markers you have to set up in order to have like the way I have it. So okay, so we showed some of the brackets. We want to start to write this. So the algorithm, did I already explain here? Okay, let me finish this part. So here is the page on how to code it in Emacs Lisp, and did I explain the algorithm? How do you do this? Okay. Yeah, so here is basic algorithm. You just go through, let's say you only care about the parentheses. So you go through the text from beginning, you find the first parenthesis. Each time you find a parenthesis, you want to check if it's already in a stack. You want to create a stack. So every time you find the parenthesis, you push it to the stack, okay? And you also check in the stack if the last character is a left paren. So if you found the right paren, you check the stack, see if the last paren is a left paren. If it is, then you can remove that because they matched. So remove it and ignore the current one. Find the next paren, okay? Now suppose you find the next paren, which is again a right parenthesis, a closing parenthesis. You check the stack, is the last item a left bracket paren? If it's not, you got a problem. You got a mismatched bracket. Then you just record the location, the position of the current cursor, or report error or something like that. So that's the basic algorithm. Find the next bracket, push it onto the stack, and check if it matches with the previous one on the stack. If they are both open, you just keep pushing until you reach your closing bracket, and then you check the stack. If it's a opening bracket, then they cancel each other out. Then when you reach to the end of file, check your stack. If it's empty, it's all good because all canceled out. But if there's some bracket on the stack, you got a problem because that means you have some opening brackets that's never closed. So that's the basic algorithm, okay? So here, this page already explained how to do this, okay? But now there is a Golang version. So back then, like 12 years ago, in 2011, 13 years ago, 2011, I did a programming exercise asking people to write this program. So there's a spec, and we have quite a few solutions. We have Emacs Lisp, and someone contributed a Python solution. Okay, so you can see Python solution 2011. Then there is another Python solution. I didn't check. Yeah, some of them didn't work. So for some reasons, and I didn't go into detail why they did. So there's Python 2.6, Python 2 solution. There is and what is this solution? Another Python solution. This is also incorrect for some reason. And there is a Ruby solution. Who coded this Ruby? I don't remember. I have Robert Clem. Okay, I don't remember who that is, but these are 2011. Then there is also another Ruby solution. There's a Perl solution. And there's Common Lisp solution by Matt Hu. I don't remember who's that guy. Common Lisp solution. So, and there is a ANSI Common Lisp, C Lisp. Okay, I recognize this guy, Pascal J. Buchanan. He's a Common Lisp expert. Okay, so I would trust this one to look further. Oh, pretty short. So anyway, so yeah, so that's interesting. Oh God, we spend so much time to go over this. So let's I want to write this command, so let's do it. The reason I need, because I need it, because I have 10,000 HTML files and I use brackets extensively. So that's why I want to have a command. So let's just start to do it, okay? Okay, let's start to do it. Now the easiest way is actually just to check my existing code, okay? So here is a test file. Let's open that file that doesn't exist. Okay, so let's create it. Let's just add a bracket. So what kind of bracket do you want? Let's say square bracket. Okay, save it, close. So that's a test file. Now this is the input directory because this program is supposed to go through all directories. And this code is to make sure the input directory ends in a slash. Okay, that's a Emacs Lisp convention. If you have a directory path, it should end in a slash. Okay, and also this home side is old. Okay, so we need to the new, because back then I'm on a Mac or something. I'm on Linux, but now I'm on Windows. So this directory should now be users XA instead of home. Okay. Let's just go to keyboard. Okay, that's this directory. Okay, copy the file path, go back here, paste it, and there it is. Okay, so now this make sure the directory end in a slash, and if the directory does not exist, stop, report it. Okay, and here is the part where it gets the argument from the shell. But we are not doing that today. And here is a list of brackets. What kind of bracket you want to check. Okay, fully documented. That's my nature of my code. All my code, every variable is all, every variable command or function is all fully documented. That's my style. Okay. So then you got X rejects, what is this? Reject string of all pairs to search. Oh, okay, so we started to get into the code. So you got the list of brackets here. Then, they come in a data structure called associative list in Lisp. Okay, you can look up my tutorial on what associative list is. Basically, it's a list of pairs. You can see it here. You go to loop, data structures, list. And what is a list? You go all the way down. Then you see special list. Okay, so association list, which is just a list, but each element is a pair by this count structure. Okay, so that's what a list is. Okay, am I good? Yes. Okay, so you got the brackets. Then you want to turn a bunch of brackets, a list, into a regular expression. Then what is this commented out? Okay, that's a different way. Generate regular expression from brackets. Okay, that's a different way to do it. I don't remember, so I have to look at the code. Let's so there is lambda. Oh, then you map concact. Okay. Oh, you map concact, make them into a string. Okay. So so there is the toothpick syndrome in Emacs Lisp regular expression, because every backslash needs to have double backslash, and some of the regular expression, because parenthesis is literal in regular expression in Emacs Lisp. So if you want to do capture, you have to have a backslash in front of the paren. So you end up with 2 backslash in front of paren. And also for the alternative sign, you need a backslash. So anyway, you end up with 4 backslashes there. So okay, anyway, so this is regular expression. Then so this X bracket match list is a stack, I suppose. Okay. Then my operative button, what is that? I don't know what is this one. My operative button. Oh, no documentation. That's that's interesting. This must be a hack. Get file path from properties. So what is this? My operative button. Okay, so it must allow you to click and go to yeah, it allows you to click and open a file that has a mismatch paren, something like that. Okay, yeah, it opens the file. You can see it split the window, open the file, and go to the chart position. So it jumps to the file that has a mismatch paren at a particular position. This let's rename this. Okay, operate button. So rename XAR OP button. Okay, it's used somewhere. Okay, used twice. Okay, so then my process file. So this part is actually processing a file. So let's expand it. Okay, so this part is actually, given a file path, it will go through it and check the, yeah. So let's rename it XAR do paren file. Okay, let's say check paren file. Okay, rename that, rename. Okay, go to the top, rename again. Okay, it's all good. Check. Okay, now the name makes more sense. So check paren by file path. Okay, a bunch of variables. So there it is. Here is our stack, starting with empty. Now, a stack data structure in Lisp is just a list. Okay, list is the best structure for a stack, because when you have a list structure, you can always add things to the front and take one thing out from the front. So every time you add one item and remove one item, that's a list. Okay, so char is the current character. Okay, God, this is a lot of code to go through. Yeah, but it's not too big. Okay, so for example, I delete that whole function, undo, single key press, new buffer, paste it, go to the top. Let's make this XAR Emacs Lisp mod and shrink. Okay, so it's 50 lines of code. If you remove the comments and white space, it's 40 lines of code. So that's all, not too bad. Okay, close that. So anyway, so we have to go through this because this is the heart of the thing. Then, okay, then what we have, then done deal. Where is the part that checks all entire directory? That's here. You see. So you declare an output buffer where you want the error report to go to. Okay, then you map this function check file to a list of directories. The input. Okay, and you also include a regular expression. What kind of file extension you want. So this actually should be moved because this is a variable. Sometimes you don't always want HTML. So let's move this to, yeah, let's start to work, get this to work. Okay, so yeah, so okay, so let's go here. Let's make input file a test file. So okay, I want wait, so file name extension. Okay, let's put here. Okay, something like that. Let's just say, okay, so HTML. So that's a file name extension. Then you need to turn this into, yeah, let's do that. Why don't we? Okay, that you need to turn this into that, so you can just do it by, let's do it manually. Okay, concact that by a $, and in front you want double backslash and dot. There it is. Okay, so you don't need this part. So this is now better because this file name extension is usually free, it's considered to be part of the user's option. So that's why you don't want to hard code it. Okay, wait, undo. Okay, so there. Okay, yeah. So, but another thing we want to do is that, and and this bunch of commented out. I forgot what, why, what are these commented out? What kind of? They must be alternative implementation. And okay, but anyway, so you can see, save it, close, reopen. So you can see one of the most important thing is this input. Okay, let's search for occurrences of that. So there and there. Okay, so now whatever below this line is actual code. Whatever above this line, these three they are user inputs. It's an important distinction. Okay, so these are user inputs. Let's remove that. So, and now in this program, this X input is yeah, they okay. That's all their occurrences. Check exist. Make sure end in a slash. Okay, when you write it out, it's much easier for other people to understand. Check exists. Okay, now we have full documentation, and this part is, yeah, this part is about getting the argument from the command line. Okay, right now we don't care. Okay, so now actually the bracket list, you should also be a user option. Okay, it shouldn't be part of the program. It should be a user option. But there's a problem about if you turn the list of brackets into a user option, you have the problem of designing an interface. For example, how do you want this? How is a user supposed to? By what means they list the brackets? For example, you can go by a text file, or you can do it on the shell command line, but that's usually problematic because then what if user gives, they typed mismatched bracket, or also it's very tedious if every time you require the user to type all these different brackets. So you want a way for the users to say, just check all kind of matching brackets, and you also want be able to let the user just say, I just want to check parentheses, or I just want to check, the common ASCII brackets, paren, square brackets, or curly bracket, like these three. And also another common one is you see these three are common, these three, and another common one is the curly quote. That's frequently got fucked up. So anyway, these are brackets. You want a way to be able to let the user input them in an easy way. Okay, that's another problem by itself. You can use a menu like, but anyway, let's worry about that later. Right now, I just want to turn this file into a command. Okay, then we gradually worry about the other thing. So this command, first of all, we want to test to see if it runs. Okay, then so that's what we want to do. We want to test. Okay, just run this file and check if it runs, because this is 10 years old code I haven't touched. So to do that, you don't want to have the input be a directory. Well, because a directory has lots of files, you want it to be able to check one file. Okay, so let's modify this. So if this input if it's we can make it so that it's the program will check if it's a directory or not. If it's a directory, then go through all the files in a directory. If it's a single file like that, then just check that single file. So in order to do that, so right now it's it takes an input directory always, because you can see the program over here it's getting a list of directories. So you want to modify here so that if this input is a single file, then just do that single file. So that require okay, let's do that. That requires me to change a few variable names and so on. Am I doing good? Say hi, guys. Okay, so okay, so what are we doing? So we want to make what's the best way to do this? We want to be able to check a single file or a directory, right? So right now it's checking a directory. So let's do this. Okay, let's do hey Victor. Okay, great, thank you guys. So let's do this. Let's just rewrite it here, new, fresh. Okay, so people can much easier to see what we're doing. Okay, so we need a file path. Okay, there it is, a file path. Validate brackets of current. Should it be a buffer or file path? You see, when you actually code, you have lots of these little design details, which is important. For now, let's just say a file path. Okay. Let's just say validate bracket of file at file path. Okay. Later on we can change that. Okay, so file path, so make sure in the stash we don't care, check if not exist. We want to check if it exists. Okay, so here when not file exists, this is the file path. What? Let's say God, why is that? Okay, never mind. So file exists there, if not, user error. Okay, let's do that. Okay, so that take care of that. Then you need the brackets. Okay, so we have a bunch of brackets. Let's rename it lowercase. Okay, that's a variable. Okay, local variable. So so you can actually put it here. There, so we got a bunch of local variables. So for now, don't worry about that. Don't worry about that. Don't, what? Wait, what did, it's interesting. So we just only check the curly quotes. Right now we just only check the curly quotes, okay? So bracket is defined, so this needs to be a list, so we gotta give it a quote. That's how Lisp is. So this is association list of pairs, okay? So we don't care about brackets here. Then we need the regular expression indeed. So we need to turn this to, so we have brackets here, then okay, so let's put it here. So let's rename it because I don't want it capital. Okay, so there is our regular expression, and there is our bracket. Supposedly this will turn these brackets into a regular expression. Fantastic, beautiful. Next please. You know, like 20 years ago in the 1990s, there's this Vietnamese restaurant. Every time you go there, you know, I was working as a typist, so at lunchtime, it's a restaurant, you know, it's a cheap restaurant. So lunchtime I go there, then you hear the Vietnamese women says hippiness, hippiness. That means, may I help you? May I help you with the next one? You know, like hippiness. Turjak, hello. Is Lisp relevant today? I think about AI models and the neat math it takes. Okay, is Lisp relevant today? Not really. Okay, you want to know the short and simple answer? Not really. I mean, what? So put it this way. If you are doing AI, most of them today is not written in Lisp. Okay. Vast majority of AI code is written in Lisp back in 1980s, 1990s. Okay. But not today. Today, you will rarely, if at all, possibly find one single, large language model, so-called LLM, chatbot, or whatever AI written in Lisp. There are few, okay, but compare, in 1,000 AI programs today, big ones, useful, valuable ones, you'll find, maybe 1 in 1,000 that's written in Lisp, okay? So maybe that answers your question. Is Lisp relevant for AI? Okay, so, but is it relevant? Well, that depends on you. If you are coding, for example, if you are doing text processing, that's what we are doing today. Text processing, extremely useful. Validate. Also, you can validate HTML. For example, okay, we are digressing, but let's do digress, okay, because it's fun. For example, here's my keyboard blog. Okay, there are 1,000 HTML files in my keyboard blog. Everything about keyboard you need to know. So you go to the directory, you can see, magnify, go to the bottom, 1,059 files basically. Okay. So I want to validate, I want to know if I have ever mismatched tags. For example, this XAS monitor 2008, okay, XAS monitor 2014, then this broke, then XAS monitor, let's go to XAS gaming machine, okay, copy the file path, close that, open that, okay, showing browser, XAS gaming machine 2021, this is my current machine. So I want to know, let's go to the top, if I got a mismatched tag, HTML is basically like parentheses, right? So I can call XOR validate. Okay, there's a shortcut key. Let's see. Tab H. Wait. What? Tab. Okay. Tab UH. There it is. You see at the bottom. Looks good. And the tab UH command you can see is that one in the pink window. XOR HTML validate HTML buffer. So it just validated, So what if I cut out this part and put here? So now I got a mismatched tag. We got a closing tag H1, then here. Then, now let's call that command again. Tab UH. Error. File. This file, XOR gaming computer, closing tag H1 at position 313 to 318 does not match last open tag main at position 305. You see? Fantastic. Is that beautiful? Now let's say I save this program without fixing it and I close it. Now let's check the whole directory, okay? This 1000 files, okay? So metax XOR validate XML enter, okay? Which this enter, okay? Wait for 5 seconds. There it is. Error this and error that. Let's see what is error. XOR gaming computer, okay? Open that. We already, so we already know this file is bad. So let's fix it, okay? Fix that. Save, close. Now the other error file, what? Oh, same thing. Actually, just that single file. It's basically saying the same thing, okay? So now close this and do again. XOR validate XML do it. This directory. 1000 files. Done validation. You see, done validation in this directory. Any error are printed, if any. Looks good 1003 times. So there's no error, okay? So that's the power of this task, this program. Let me show you the source code. By the way, we coded this last year. So if you go watch live stream, you can see this command, okay? Let's go to the source code. This is very much related to what we are doing today. In fact, it's a bit more complex because HTML tags, they are just like brackets, except they got more characters, okay? So you can see HTML engine, the source code there. And we did code this live about last year or so. So you can go watch it on my YouTube. Fantastic. So that's the code, and of course then the other parts, So the main code is just this part, but then it's calling, you see, HTML validate XML file, fantastic. So what we are doing today is very similar. So okay, I was talking about text processing. So this task is called text processing. And for text processing, nothing beats Emacs Lisp. Not Golang, not C, not C++, not Java, not Python, Python idiots, not Perl, supposedly the most powerful, Swiss Army knife shit. Suppose the most powerful text processing. No. Not Perl, not Python, not Ruby, not Golang, not Rust, definitely not Rust memory idiocy, not Haskell, but functional programming, no, not Haskell, not OCaml, not Microsoft F#. They are all lackluster when you want to do text processing. Emacs Lisp, nothing beats Emacs Lisp. I talked about this many times. Why? but what's the reason? Well, the reason is Emacs Lisp is designed for text processing. More specifically, because you have the buffer data type, you can programmatically move a cursor, do search regular expression forward and backward too. And you can say position, you can narrow buffer, you can narrow to region, all sort of things. And data structure and functions that's designed for text processing. Not even Wolfram language, the most powerful and beautiful programs, is better when you want to do text processing. Okay, that's Emacs. Can Emacs do this? No. But if you want to do this validate, nothing beats Emacs Lisp. Okay, nothing. Basically, there's no other system. Not Vim neither, because VI or Vim or NeoVim, they got a lousy language. Emacs Lisp. Okay, so that is, so that answers your question. Is it relevant? Is Lisp relevant? That depends on what you mean. If you want to do text processing, nothing beats Emacs Lisp. If you want to do, for example, language design studies, what is the effect when a programming language has lazy evaluation? You constantly need to trick your compilers or trick your syntax. If you want to do that, Scheme Lisp is probably the best choice. Not Python, not all the others. Okay, not Golang, not Haskell. Okay, so depends on what you mean. So in some cases, Lisp is very still useful, and yeah. Okay, so then we digressed a lot. Let's close this. Let's go back to our keyboard block. Close it. Let's finish this. We'll be done pretty soon. Okay, so we got a stack. We got a regular expression, and okay. Then next, this is the stack. Okay, let's put the stack here. The stack code. Okay, and this is a variable. Let's push the variable. We have to declare a local variable, and let's rename it stack. Okay, well, let's not. I would, but we gotta finish this in live stream. It's already an hour. Shit. Okay, and here is the code that checks the, actually here's the code. We don't, okay, so let's paste the code, and let's just start to, we don't need X file path. Okay, we already declared. Okay, so let's do it here. Open a new buffer, go to the top. So our file name is that. So change all X path to what is this? X file. Okay, let's not change. Okay, let's change. X file path. Okay. Change. Okay, now put it to XAR Emacs Lisp mod. So we got color. So process the file. Okay, so we already got this. Okay, stack. Oh, it's already local. What? We got some. What? Okay, when T not string file in case you want to skip certain files. Okay, buffer, get buffer, create buffer, go to char 1. Then we search for X regular expression. Yeah. Oh God. So yeah. So what we do? So we I mean, we either work on here or so. But what is this then? What is this bracket match list? Such. Oh, so actually you need it. So it's begin empty. Then oh god, so shit. we got a situation. We have two branches going on here. So which part should I focus on? So this one, this is a new. Okay, it's maybe better to focus on new. But what is this bracket match list? What is this supposed to do? Search. So it begins as an empty list. Okay. Then when not equals stack, set that to cons x stack. So x stack. Okay, I don't know what is going on this. Okay, I'm discouraged. Should I continue? God shit. Okay, I want to be able to at least have a one command that just do the current file. Okay, so okay, let's set that goal. Just one command. Okay, 20 more minutes should be it. So this supposedly already do it. Okay, so you create a stack to push for the brackets. Each entry is a vector, char, and position. Oh, okay, also give a position. Then x char is the current char found. Set q. So wait, so let's highlight it so we can see where it occurs. So then if it's true, what is this doing? Wait, is this even valid syntax? Okay, so it goes all the way down. So basically it was some condition. So so when so I want to skip all directory whose name start with XX. No, I want to skip all files whose names start with XX because that was my temp file. But now let's just say condition is always true. But this, okay, yeah, so we can actually ignore this when. This when goes down all the way to the bottom. Okay, so now you get the buffer. You create a buffer. This is a temp buffer. Okay, that create a temp buffer without undo. When you create a buffer and you name it such that the first character is a space, that means it creates a buffer without recording undo, which is very useful when you are processing files programmatically, because you don't want to undo. Undo slows down. You don't need to. So you set the buffer. That means make the buffer current. Then you insert the file contents of the file path. That's good. Okay. Then you go to char, which is the beginning of the buffer. Okay, then you search forward. Okay, then you search forward for the rejects, which is the first the regular expression here. Okay, so you search for word. When you found it, so while it is true, when you found it, you set the position, the current cursor position, then you set the character. So the character push, get purpose substring, you get a character, okay? Current character, current position, then you print for debugging purposes, okay? Then is the closing char true? So, there it is. Wait, this is a local variable, is closing character. And another local variable, xmatch opening char. Okay, so those are booleans. So let's clean the code so it's easier to read here. You don't need a nil here because every local variable initialized to nil. So, my Lisp has improved since like 14 years ago. So let's remove that nil. It's redundant, okay? Okay, so you just got two local variables here. Then, so now we set its closing character Q. Q means a question, okay? In Q, the naming of ending with capital Q, that's the Wolfram language convention. Whenever you have a function that always return either true or false, you end that function name or variable name capital Q. Now the Lisp convention is P, but Lisp is not consistent, for example, in Emacs Lisp. But anyway, so I was just using this, okay? Today, anyway, so it's not too important. So it's closing character Q, okay? So you can check whether the current character, the current bracket is a closing one or opening one. So you do that by using the association function. Okay, that returns true or nil. Then is the okay. So if it is a closing character, then you set this boolean match opening char, whether it matched or not. Okay, so wait. So if it's closing character, you want to find the X matched opening character. So that is the matching character, I think. Oh yeah, okay. So wait, so yeah. So this is closing character is actually a const pair of two brackets, one open, one close. Okay. Then if it's found, if it's not nil, then you want to set the matched opening char. So you want to find a character that matches that closing paren. Okay, yeah. Then debug, print debug information. Then okay, if the stack is not empty, car stack. Wait, what if you have a empty list? What does car return? Let's try it. Run it. Okay, it still returns nil, so that's good. So if the stack is not empty, and equals to element car stack 0. So okay, so we are checking the item on the stack. If it's not empty, and the item on the stack is the opening bracket of the current bracket, okay, then you remove that item on the stack. Okay, that's what you do. Fantastic. But if that character on the stack is not the matching opening of the current bracket, then you push it to the stack. There it is. Okay. Then you do this. This is a loop, I think. Let's see. Yeah, while. You see, so this is a while loop. There it is. Okay. So now once you are done, basically you are done because you are searching every parenthesis. I mean every brackets. Okay. So go to the end. So when you are done, when stack is not nil, you got a problem. Set q bracket match list cons. Wait. You got a problem. So you need to what? Set x bracket match list. Oh, is that's the variable. That is the variable. Oh, empty. Okay, so what is this variable for? So set that, so that was empty. Now you set it to cons. So stack. So I don't understand, why are you doing this? So if the stack is not empty, that means you got a mismatched bracket. So then you are printing the error file, right? So you also print the stack. But what are we doing here? What is this set x bracket match list? Cons. Okay, cons means you add the stack to this. I don't understand. Why are you adding it to this list? What is this list for? It's undocumented. That's not nice of me. Usually I document everything. Anyway, so you are pushing the stack to that. I don't know why, but basically you should print this. Okay, error. And let's print, yeah, so error. Let's not print C. Let's well, you need to print it. Okay, so actually you can just say messages better. So messages error. Okay, so you got error. File path. Error at file path. Then you can say stack. Okay, when you print a stack, which is a list, it's not pretty. So so I think I know what's going on now. I remember. So you see, our program, this program written 14 years ago, it runs, but it's not very robust because you see, when you find an error, the best thing you want to do is for Emacs automatically put a cursor at that position. That's an advantage. No other programming language can do that. Not Ruby, not Python, not Java or whatever. So Emacs can just open the file and put a cursor there, and highlight whatever the match supposed to match the bracket, whatever, all these kind of things. But this program does not do that. It just print the stack. So what happened when you print the stack? Well, you just see a bunch of paren. You have no idea. I mean, well, paren and position, you can't press a key to jump there. So I remember. So that is why. So I mean, it works. It does check, whether the file has mismatched paren, but it doesn't. It's not so convenient. So that's why we need to fix this. Now to fix this is well, it's gonna take another 20 minutes at least to get going because thank you. So why are you using Windows? Who is that asking that idiotic question all the time? I explained that 1,000 times as recently as 2 months ago or so. Like there's a full 1 hour discussion about which operating system to use. Okay, and I believe yesterday also, is that you asked me about that again? These now I don't know who you are. I don't know what's your intentions, but some of my followers are the Zoomer teenagers, brainless type. They come here, they want to, not necessarily you, I don't know for sure, but they want to troll. They want to get me to talk like something dramatic. These people are idiots. Okay, I'm not into those kind of things. Okay, so let's go back to code. So yeah, so this will print stack. Print stack. It's like it's just a hack. Because when you print the stack, it shows a bunch of things. It's not really great. Rather, you want to put the cursor at a location that's missing brackets and explain whether you are missing one or you are missing a left one or right one, what kind of brackets you are missing, things like that. So yeah, to fix this program, it will take yeah, I don't think I can do it. So right now we are already 80 minutes. Oh, it's not you are not trolling. It's your first time asking that. Why are you use Windows instead of Linux? It's a silly question because when I was on a Mac, then people say, why are you using Mac, not Windows or not Linux? Well, on Linux, people will say, well, not using Linux or I mean Windows. They're just so like. So let me talk about this for a minute, just to answer your question. So usually when you ask that question, why are you using Windows instead of Linux? There's an implication. The implication is that you probably prefer Linux. You probably don't like Windows. And more, likely you think Windows sucks and you think Windows is does not respect privacy and things like that, while Linux does, and Linux is more powerful, it's more open source. Therefore, why are you not using Linux? Come on, because Emacs is part of this Linux. I mean, it's GNU Linux, okay? Richard Stallman, that's a slightly different camp. Free Software Foundation versus the open source fuckheads. Richard Stallman considered the open source as scums, okay? Maybe you don't know that, but I'll tell you. I talked about this many times. So why am I not using Linux? Because in my opinion, Linux, Mac, Windows, they have kind of pros and cons, okay, each one of them. There's no, but these pros and cons such that there's no easy answer to consider Linux is the best, like without any criteria. You can absolutely say, oh yeah, Linux is the best operating system. Besides, it's free. That's one of the big advantages. That's why you are using Linux. If Linux costs you $20, you will not use Linux anymore. I can tell you right away. Okay, not to consider about privacy or how superior technically it is or whatever. If Linux costs you just $20, all the Linux fanatics, they will stop using. Even though it's still open source, but they'll stop. So there's no easy, so there's pros and cons among these three operating systems. So there's no easy answer, okay? If you are, if you don't want hassle, if you also play video games, Windows is the best. If you are very concerned about privacy, you worry about, the boogeyman or some glowy, then Linux is probably your best choice. Every day you just sit in front of the computer. How do I connect to USB? My USB, I bought this USB stick. It's USB 3.4. Oh, but I can't get it to work. When I plug in, nothing comes up. You go to, Linux, you chat with your Linux buddies. Oh, you gotta go, go to the shell, kernel, this, then, after 1 hour, it worked. Oh, Jesus, the beauty of open source. That's Linux. If you are a dev, if you all you do every day is Emacs, which is better, Emacs, Vim. You don't care about V or whatever, VS Code, whatever. VI, Vim, Linux. I must Linux. I must Unix. I want command line. I want talk about kernels. That's my love. Linux is best for you. Okay. You are dev. You don't play game. You don't play games. Okay. You or you don't do other things. In Linux, okay. Now, if you are the type who wants the most best design, you don't have to worry about how do you want the drivers or the kernels, whatever crap, and things just work out of the box, including hardcore programming and technical computation like Wolfram language. If you are into that, Mac is your best choice. The price you have to pay is that everything is twice as expensive. You buy the same computer for the Mac, it's, for Linux, it's $1,000. For the Mac, you pay $2,000 for the same thing, everything. So that's the Mac. And also, you don't get, it supports your privacy. There's no pop-up like shit going on. And there's no open source fanatics shouting at you in every screen. Please support open source. Donate to this project. Please, fuck. You just want to get on with your life, code, or play games or whatever. Oh, by the way, you cannot play video games neither. If you want to play the real video games, basically Windows is your only choice. Okay. And I talked about this in my previous videos so many times. It's one of the most shallow questions. Like people don't, they don't. Anyway, I hope that's good enough answer. Okay, so back to this problem. I don't think, by now we talked for 90 minutes and it will take me another at least 20 minutes to, so I think that's it for today. We didn't explain the full, but we explained much of the Lisp coding, and also for those of you really into my Emacs Lisp, okay, so you can just go to my Emacs Lisp website. There is, go to Emacs Lisp tutorial, and there is a new section. So, for example, Emacs Lisp Basics, everything you need to know from the ground up on Emacs Lisp. The basics, Boolean, string, what is a string, how do you look up documentation, what's a number, what kind of flow is, do they have integers or floating numbers, what's a syntax, what's Boolean, what's a variable, how do you define local variables, how do you do if then else conditionals or loop, and what's a data structure, list vector, and how do you create a function. So this basics, and then you have Emacs Lisp, but there's a new section, okay, video tutorial, because I've been doing videos for 3 years, so there's lots of these past videos, which one, so I collected here. These are good videos. Each one is about 1 hour long, and they focus on one thing. For example, this one is Software Keys Introduction. Okay, and if you want to learn Emacs Lisp, so this one, for example, this one is about Emacs Lisp workflow efficiency. Then if you let's go back, and then if you want to learn Emacs Lisp from the ground up, there is that one. That one, Emacs Lisp for beginner. So I talk about, how do you create variables and all that. And then, okay, so you get the idea. So this collection of Emacs and Emacs Lisp video tutorials. Okay, that's it for that. I think that's it for today. That's it. Anything else? Any other questions? 8 people. Okay, so that's it for that. Thank you, sir. Thank you, Tarek. We shut down in 1 minute. So I'm doing, I need this command myself. So at least I spent, I went through, we went through the code, have some idea how it works. And we also demonstrated the HTML validation, which is, a bit more complex than this, but essentially the same thing, exactly the same problem. So I did a video, like I mentioned before. If you search for validate, there it is, you see. XR Talk Show, 2023, June 25th. Emacs Lisp, write a HTML and XML validator. So there it is. We wrote it from scratch in real time. And then part 2. So that's what I demoed today. So thank you guys. Bye. So another question, Subhajit. Are you going to solve this problem in your stream? It's very interesting for me as a beginner, and thanks. Oh, okay. You want to see the solution? Yeah, okay. Let's try to solve. Let's try to do it quickly, okay? Since you asked for it. So don't forget to donate, okay? If you donate me, of course. But since you asked, let me just do it. So we want to write a function that quickly just check a file and tell you if the parentheses are or matched, okay? So let's just quickly do that. Now I'm just gonna quickly do this. So we don't want this, whatever that is. Okay, so buffer stack. So let's copy that buffer stack. So so there's a buffer, there is a stack, we need local variable, there's a char we need, and there's a position we need. Okay, local variable, copy that. Okay, so that's local variables, and then set stack empty. Okay, stack. So empty list we don't need. Actually we don't need this. Okay, anyway, so because by default stack is nil, so nil is equivalent to empty list, but this part I need char. Okay, empty string. So let's then let's copy this whole when thing, let's put it here. So let's check the file exists. Then this is regular expression. Wait, does this occur here? No, wait, it does. Okay, so it occurs there. So okay, so let's just copy that. Copy, go back here. So paste that here and go up, and when we have the regular expression, so we need to rename this rejects because we have a name that there. So rename this capital by lowercase. Okay, fantastic. So this is a regular expression to search the brackets. Then let's prettify the code. Okay, so when it's true, always true, xbuffer do we have? So we got xbuffer, local variable, and file path. Now what is this file path? Okay, so we need to rename that, I think. Yeah, so go up here. Yeah, so the new name is that. Okay, so so we need to rename this file path by one, two, three, four. Okay, such double check. Yeah. So we are back here. So when whatever is always true, then create a buffer. Okay, X buffer, search for that. Search, yeah, we got a local variable. Then make it current set buffer. Then insert the file content of the buffer into the temp buffer. Go to the beginning of the buffer. Then while search for the regular expression, search, so that's our regular expression of the brackets. Then the position, okay, position and char, we got the local variable, yes, position and char. Okay, then where do we have that? That's a local variable. Okay, then that's also a local variable. Okay, then if not empty, then print. Okay, format, let's print it out. Format match this top item. Okay, so if it's matched, we don't care. Yeah, then we remove that from the stack. Otherwise, we don't care. So otherwise it didn't match, we push it to the stack, then we are done. Okay, so print current stack, we don't care, so we don't okay, prettify the code. Actually, let's remove the print. Okay, because let's make the code compact. Okay, so prettify the code. So we check the current bracket, push to the stack or remove that from the stack. Then we are done, because this is a while loop. You can see this is a while loop. So that means it reached the end of buffer. Okay, then if the stack is not empty, so you can, if not equals to nil, so you can see so if the stack is not equals to nil, I don't know what that is, so remove that, we don't need it. So if it's not nil, we got an error. So error at file and print the last character of the stack. Okay, fantastic. Let's just do that. So that should do that. Then kill the temp buffer. Okay, then also uncomment clean the code. Now let's clean the code. So what is this? Found char. Let's remove that. Okay, wait. Let's make sure. Okay, compact the code. So if it doesn't match, we don't care. Okay, so actually let's remove the when. Okay. Okay, and let's make that one line. Let's make let's remove this redundant. Okay. Actually, let's check just for this square bracket because it's easier to see. Okay, so we only check for square brackets right now. Okay, so let's clean. Fantastic. That's it. That's our code. How many lines of code? 39. Okay, shrink a little bit. That's our code. So now eval the buffer. Now we evaluate the whole buffer, so we can actually call it. Okay, so this takes a file path. So we want to meta X and call this. It won't work because it doesn't have a file path. So let's fix that. So you just add an interactive here. So when you call this file interactively, I mean when you call this command by meta X, it will automatically add the current buffer. The current buffer's file path will be passed to the argument automatically. Okay, when you call this by metax. So this is how you do. So all you have to do is buffer file name. Buffer file name is a variable that returns the current file path, full path of the current buffer. Okay, so that's done. Now eval the buffer. Now let's go to some test file. Okay, let's go to, we had some test file here. There it is. Okay, open it, magnify. Let's add some more. Okay, now metax XOR validate brackets. Enter, please. It didn't say anything, so it's good. So when it's good, you need to print fantastic, you are beautiful. Okay, so let's modify this code when. So you see, we instead say if stack is nil, so you don't need to say equal, you just say stack. So if it's empty, that means it's nil. So it's nil, message, fantastic, you are beautiful. Okay, no error, fantastic, no error, you are beautiful. But if it's not nil, then you got a problem. Okay, so it's Chiching, who is that? Thank you, Sajid. Thank you. So if stack so if stack is nil, fantastic, you are beautiful. If stack is not nil, then you need to message, you got a problem. You got a problem at this file path, and message, you got a problem in this stack. Let's print so we know what kind of thing it's going on. So this bracket problem, okay, something like that. Okay, this is just quick hack to get this done. Okay, so we modified it. Now evaluate the buffer, go back here, metax XOR validate brackets. This, wait, we got this bracket, you got a problem. What a problem. What? So if stack is true, oh, we got it reversed, so this gotta be reversed. So if the stack is true, that means you got a problem. If it's nil, fantastic. Okay, evaluate the buffer. You can see my command calls in the pink window. XOR run current file. That's my custom function to eval buffer. Or you can just call metax eval buffer. Okay, so eval the buffer. Go here. Metax XOR validate brackets. Fantastic, no error. You are beautiful. It says. Is that true? It is true. Oh, fantastic. Now let's introduce an error. Okay, let's delete that. Okay, now you got fucked up. Metax, do it. Oh, it says fantastic. You what? Okay, we got a bug. Let's try to delete that one. Okay, let's run it. Yeah, what? It's always fantastic. We got a bug here. So God, so you need to go into the logic of the stack. So push stack. Wait, what is going on? So if the what is the rejects? Let's double check what is our rejects. Okay, the regular expression string. Okay, so messages rejects is, maybe this rejects is wrong. Okay, evaluate the buffer, go back here, call it fantastic, no error. But what is rejects? Okay, rejects is that is in okay, well, oh, I know, because when you have, when you see the square bracket has special meaning in regular expression. That's a pain, because the square bracket in Emacs, this regular expression, it means a character class. So instead of okay, so so let's cheat. Let's just not check square bracket. Let's check the paren instead. Okay, let's check paren instead. So evaluate the buffer. Let's go back here, remove that. Let's say paren, and some more nesting and paren. Okay, run it. Fantastic, no error. But now let's remove that one. Okay, run it. It says still beautiful, but it's actually not true. So what is this? God, regular expression. The regular expression. What is, okay, so we need to check the regular expression. What is this? It's a pain to figure out the backslash. So okay, so there's a quote rejects. Okay, quote regular. So what's the comment? In the bracket list, do we have square brackets uncommented? Parenthesis also has meaning. No, parenthesis is literal in Lisp. Okay, but anyway, there's something we need to figure out here. So our code is not correct is because okay, so I mean, okay, let's, for whatever's sake, let's just try the this curly quote. So so it absolutely no special meaning. So okay, so close that, curly quote, curly quote. Okay, so we got curly quote. Yeah, but curly quote is hard to see. So actually, so let me get fancy. Let's use corner quote. Okay, corner quote is one of the Unicode character. Okay, so remove all that. Corner quote. Okay, now validate bracket, no error, fantastic. Now delete that, run it, no error, it's beautiful. Okay, you got something wrong. So what is the regular expression? The regular expression, let's do it again. So what is the regular expression? Okay, evaluate. Oh, I forgot to eval the buffer. That's right. So delete that. Okay, go ahead, do it, no error, you are beautiful. But that's not true. So if you look at the regular expression, it's that or that is correct. You see, the regular expression is correct, I believe. So why is this always no error something? If stack. So let's say that we know this is gonna be wrong for sure. So code validate bracket, no error, this is wrong because we at least pushed 2 opening brackets there. So now let's print stack. Okay, print x stack length. Okay, length is length. Okay, x stack. Okay, eval the buffer, go back to this buffer, call the command, validate brackets, go to the messages, stack length is 0. This is wrong. Okay, so we didn't even push it to stack for some reason. So shrink, what is this? If stack is not empty, hey, wait, why is this check emptiness? Yeah, this is wrong. Okay, why do we have to check empty? If stack set stack counter stack set stack counter. So if it's not empty, and so wait, did we clear? So stack is nil here. Okay. Okay. So stack is nil. So if it's not empty, an element call stack 0. So what is the stack? Each entry is a vector, char and position. Okay. So you want to, each entry in the stack is a vector, char and position. Okay. So okay, I need a break. So if it's not empty, then you get the first element of a stack, and you get the zeroth component, which is the character. So if that character matches the matching bracket, then you remove that stack. Okay, set stack to the counter. If it does not match, now what if stack is empty? Oh, you need to get rid of this. Okay, you need to more, because when the stack is not empty, so when it's not empty but it doesn't match, so the emptiness should be a separate check. Oh god. So okay, let me just quickly do this, okay, without thinking too much. Okay, so this block, okay, this block of code, we need to rewrite it. Okay, let me rewrite it here. Okay, so first of all, so okay, so let's rewrite if stack is empty. So if stack is nil. Okay, so if it's nil, then okay, let me just so if it's nil, if the stack is nil, simply push to it. Okay, actually you need to push it and also make sure the current bracket is not the closing bracket, otherwise it's an error. Okay, so god, so oh, so actually the stack is char, position, and also file path. Okay, wait, char position. Okay, char and position, not, let's not push file path. So you got a vector, a character, current character, and the position, then set stack. Okay, so actually you say push. You know, this is my old style. Today I would just say push instead of using the cons. So push to stack, and what do you push? You push that. Okay, so that, okay, so basically if stack is not empty, you need a lot of conditions here. Okay, so so if stack is empty, wait, if it's empty or not empty, So let's document because it get confusing very fast. So if stack is empty, what do you do? Make sure check current char is not closing. Okay, if it's closing, you got a problem. So how do you check? Well, here is okay. So this actually we comment out. No opening bracket. Okay, that's right. Then okay, let's just say that. Okay, let's not worry about anything else. Okay, so if it's closing, otherwise stack is empty. Okay, so now it's empty. Check the current char is not closing. If it's closing, you got an error. It's not closing, you push it. Okay, so okay, now when it's not empty, what you do? So when the stack is not empty, you need to check this thing. Okay, check this. Okay, you get the element from stack and first element. Now if it's the matching, it matches the opening char for the current bracket, then it's good. Then you remove it. Okay, so then you just say pop. Okay, so these days I just say pop, pop x stack. Okay, that just remove the first item. Yeah. Otherwise, so when it's not empty and the one on the stack matches the is opening, you remove it. Okay, but if it's not opening, you need to push stack. Okay, so push again. So push this. So there. Okay. So and this statement that we don't need anymore. So let's see. So now it's beautiful. So instead of this thing, now we have the this thing. Okay, so remove that, evaluate the whole buffer. Okay, now go here and remove the message buffer, delete it and restart over. Did we evaluate? I think we did. Call it. No error. You are beautiful, my ass. So eval the buffer, make sure we eval the buffer. So, and let's do again here. Call the command validate. Fantastic, no error. Stack length is 0. That's incorrect. Ah, God, what is going on? Shit. So did we actually clear? Wait, so what's going on? Stack brackets. Okay, now that's association list, right? Yeah, that's correct. Association list. regular expression. X buffer is a temp buffer, okay, and then stack is empty. It's by default is neo, so we don't need this set thing because stack by default is already a neo. So we got stack, then we got char temp variable, then position, so stack, so we got a char. So char is the current char found. Okay, wait. Okay, then when not file exists or use error, okay, then we need to create our regular expression. That's right, regular expression. Is there anything wrong? No, the regular expression seems correct. Okay, then create a temp buffer, set it to current, then insert the file into it, then go to char. So fuck. Search for word neo t. T means report error. T means no error. Okay, don't report error if you cannot find it. So it's going to change. So if stack. So why is this stack going on? Fuck. So last one, if stack. Let's print some more. Let's just print some more debug messages. Okay, let's just print the stack whenever. Let's see what it's doing. Push. Did I get this right? Push. Oh wait, we got this wrong. Push cons vector. You don't need cons. What the fuck? Yeah, push vector. So okay, so that's why. No wonder. Not cons, since we now use push. So push vector char position to the stack, right? Push, yeah. So eval the buffer, go here, close that, call the function, do it. No error, you are beautiful. Show messages. Stack length is 0. No, that's not. So why is it not even printing stack? Okay, now cut that. Let's put it here. Search forward. Message. Okay, stack is evaluated. Go back here. Close that. Call the command again. No, we got something wrong fundamentally. Okay. Let's just start to print everything. Initial interactive buffer file name. Wait, close that. Buffer file name. That's a file, right? Okay, so let's messages. File path is, let's going crazy. Evaluated, go here, call the command, do it, show the file path is that, file path is correct. Now at least file okay, save it, let's call it again, do it, go to the message buffer, file path, and rejects. Okay, now rejects is that seems correct. Now let's try to fuck with it to see if the TTHH, okay, random character. Eval the buffer, go here, close that, go here, call the command, do it, show the message buffer. There it is. So rejects, got updated, so that seems correct. So where did we go wrong? So let's remove that. So rejects is correct. Set character. The current char found. So what is oh, there. fucking idiotic. Wait, did we set it? So search forward. There it is. Set character. Yeah, there we set the character. So we don't even need we don't need this. Okay, so okay, xchar, that's just documentation. Xchar is the current char found. Okay, so let's remove that. Let's put them to where they are supposedly used. Okay, so xchar, there it is. Okay, now find documentation. Superb. Okay, so eval the buffer, and so first of all we have regular expression, temp buffer. So go to char, search forward. Let's say beep. Bracket found. Okay, let's just say whenever it found it, beep. So run it, go back here, close that, call the command -x, do it. There's not even a beep, so it's not even finding. You see, it's not even finding the regular expression. I mean, it's not even finding a bracket. Okay, that is why stack is empty all the time. So it's not even finding a so what the fuck is our regular expression? Fuck it. Yeah, kind of what. So what? Hi, Kassan, this is my first time catching you live. Hey, thank you. ZUZO. Oh, great, thank you. Yeah, we're doing Emacs Lisp today. Yeah, and well, anyway, so let's we got some problem. We are at the heart of it, so it's not even finding the bracket at all. So that means this regular expression must wrong. This is the part I didn't want to touch. Okay, so if we, so what is our what so lambda concat car and coder. Why do you need 4? I think 4 is wrong. Okay, so okay, not 4, maybe not 4. Okay, maybe just 2. I don't want to think about it. Let's just trial and error. Okay, close that. Eval the buffer, go back here, call the command, do it. Show, there it is. Symbols, values, variable is void, x bracket. Oh god, that's why. Now all this while, there it is, beep bracket found. Now it is actually finding a bracket. Okay, now set q, symbols, value, variable is void, x bracket. So we got a typo there, x bracket somewhere. There it is. Oh Jesus. So x, so x bracket should be lowercase. Search, yeah, there it is. Yeah. So eval the buffer, go back here, close that. All this trouble. Now call the command -x, validate brackets. Fantastic, no error. No, that's not right. So let's go back here. Let's see what's wrong. So rejects. Okay, so b bracket found. Yeah, I think you do need 4 backslashes. Okay, we got wrong because we misspelled the x bracket capitalized before. Okay, Now eval the buffer, go back here, close that. Meta x star validate brackets, do it. Now show the messages buffer. Okay, we got that. Regular expression is still that. Stack length is 0. Now they didn't even beep. So no beep means no regular expression is found. I mean no bracket is found, okay? So that means this, oh Jesus, this, there's a better way. Let me try to, there's a better way to create the regular expression. Our problem is this regular expression. Because, let's try it again. Because, duet show, yeah, it's not finding even. So if you have 4, it doesn't work. I think I evaluated, I don't know why. Do it again, evaluate, show the message buffer. Now it found, you see. Yeah, so this is a proper regular expression. Now it's found, stack length is 0, so now bracket found, stack is nil. Now bracket is found, why is stack still nil? So you found a bracket here, then you print the stack. Okay, don't print it yet. So you found a bracket, then don't print yet, okay? Then you set the character, the position, then you set the character, then check, check the character is closing, which one is the matched opening. Okay, then stack, okay? If stack is empty, check the char is not closing. If it's closing, you got error, okay? If it's not, you push it to stack, okay? Push the character and position as a vector, okay? Now, if the stack is not empty, then you check if the parenthesis on the stack is the matching opening one. If it is, then pop it. You don't need it, okay? If it's not, then you push the current char to the stack, okay? Now at this point, we can print stack, okay? At this point, we can print, because this is the, the while loop, okay? Then at the end, you print the stack length, okay? So evaluate this buffer. Now go back here. Now close the message buffer, call the command. Now show the message buffer. Let's see. So regular expression looks good. Beep, bracket found, that's good. Stack is nil. That's not good. Because when you found a bracket, it's an opening bracket, it should have pushed to the stack. So let's go back here. So if it's empty, is closing char q. Okay, we got it. Okay, so is that a closing character? No, that's not a closing character, okay? Then you push to stack, right? So you push the vector to stack. Okay, so why is it now? It's kind of shrink it, okay? So this stack, why? So you pushed it. stack is, so you pushed it here. So if it's empty, then you check if it's closing. If it's not closing, like the case we have, then you push to stack, right? Is a spelling error? No. Now, if it's not empty, so at least we should have one thing on the stack, right? Yeah, then you print it, so then you print the stack, okay? Evaluate the buffer again. Go back here, kill the message buffer, show it again. Meta X, do it. You see, that's a problem. Stack is nil. Why the fuck is stack nil? Fuck. Wait. It's eval. Let's try again. Do it. Stack length 0. Stack is nil. Stack length. Okay. The push is not pushing. What's the syntax? New item in place. Okay. Push. We got two pushes here. And one is the new item, one is place. Now, did we have the global variable position correctly? Yes, it includes the whole thing. So, and did we misspell X stack? No. So we have this push and it's not pushing. So describe variable push new item place. Okay, I'm really getting impatient here. So this if statement, yeah, so if stack is, oh, we got the, fuck, we got the logic error. So if stack is true, this part should be in the second part, okay? So if it's true, then that, otherwise if it's nil, then that, okay? Finally, eval the buffer, go here, close that, go here, meta X, call the command. There it is, show the message buffer. Your stack is that. Fantastic, correct, thank you. This bracket problem, this one, at position 5. Let's go to char. Go to char, position 5. There it is. You got a problem. Thank you. Yes, I know. I got a problem. But it should be solved now. Let's, now it's match. Okay. Call the command. Do it. Wait, not go to char. Call the command. Solve, validate brackets. Do it. This bracket problem, it's still got a problem. What? Close that. Call it again, do it. It says got a problem, but actually I don't think I got a problem. You got a problem. So there's some bug. So now we don't need these messages. This message is shit. Debug messages. So what? Call it. Show code show, so file path. So let's remove the messages shit. Okay, regular expression I think is correct. So what? Okay, let's check again. Yeah, so this is a mirror, so error. So let's, the heart of the code is this stack thing. So if stack, if it's true, if it's not empty, then we want to know if that the current character is equals to the one on the stack. Okay, so equals, so oh wait, not car. Okay, so you do the car, and element 0 is the, what is the stack? Each entry is a char in position. Okay, so okay, 0 is a char, right? So if it's not empty and it is matched, then you pop it. Okay, so you remove it. Okay, so this should be equal. No, not equal. So let's try. Let me show you, because there's a equality issue. You see, if you have two strings, exactly the same string, if you do equal, will they return equal? They will. Okay, so actually equal is fine. Did you save the buffer after adding the bracket? I think so, yeah. Yeah, I mean, yes, because every time I switch windows, it automatically do a save. You can find that on my Emacs tutorial if you are interested. I find this to be the best way to autosave. Every time you switch window or out of Emacs, it saves all buffers. So for example, if we make a change, you can see 2 stars here. That means it's not saved. But now if I move to here, you see it's saved. You see now show messages, you can see, saving that file. So anyway, so we want to get this going, so we just need to double check this the logic of the code, the program logic. Okay, so if let's so if stack is true, that means it's not empty, then match opening char, and also if it matched opening char. Now, is this valid? Did we write that correctly? Oh god, fuck. So now so many variables. So right, association. So if it's a closing char, how do we know if it's a closing char? Well, you check if it's in the brackets. Okay, if you check if x char is there. Now let's print. Okay, messages. Is the closing char, and the current char is x char. Okay, so we print them. That okay, so arguments is gonna be, right, we print the current char and we print is it closing. Okay, let's just run it so we don't so trial and error, because we are very tired. Unknown file extension, what? Oh wait, so we need to meta-x call this. Let's go here. So oh, there it is. Wait, what? Okay, so is closing char false for that? Correct. Bracket found. Is closing char false for that? Correct. Now next bracket found. Is closing char. Oh, there is our problem. It should be, oh no, it's not closing because it returns a pair, so it's true. And yes, indeed, the next bracket is closing. Yes, it's true, so checks out. So this closing char so far checks out. But what else is the problem? Close that, eval the buffer, do it. go to the messages. No error, okay? It says no error, but now let's introduce an error, okay? Save the buffer, call the command, do it. Problem at position 2, opening bracket, fantastic, which is character 2. Wait, what? Whatever, but anyway, it's got a problem. So now if you do cut that, paste it here, okay, save it. Now call the command. Let's go to the message buffer, clean the message buffer. Now call the command, do it, -x, do it, show the message buffer. No error, you are beautiful. Yes, I'm always beautiful. Now if you delete that first one, save the buffer, call the command, do it. It still say no error, but okay, so now actually it's an error. So, oh, error, no opening bracket. Okay, so we need to, instead of just say error, we need to stop, like print, like, so no opening, so there. So instead of a message, it should be error, okay? So error, okay? So now remove that message and remove all these messages, okay? Remove message, clean the code. Let's search for messages. We don't need those, okay? Search for a message, okay? Regular expression is correct. And beep bracket found, actually I'm pretty sure, okay? Evaluate the buffer, go back here, close that, go back here. Should be an error, okay? Because, so now we do it, validate bracket, call it, error, no opening bracket, okay? Now actually remove the messages beep. So now it's clean. I think we are done. It now works. We worked on this so much. I think you have now you get an idea how this thing works. Evaluate the buffer, go back here, close that, call the command, do it, show the message buffer, error, no opening bracket, okay? So where is it doing F? Yeah, so it just say error here. Okay, so well, that's okay. So now, but now if we add the opening bracket, let's add it, okay? Now it should be fine again. Save it, show the message buffer, clean it, okay, save it, call the command, do it. No error, fantastic. I think that's right, that's it. Now if we cut this and put it here, that's an error again. Save the file, call the command, do it. Error, no opening bracket, fantastic. We got, finally we got this problem solved. That took 2 hours and 30 minutes, I think. Oh shit. Is that right? 150 minutes. Wait, 2 hours, 120 plus 30. Damask, thank you. Somebody is watching my program. Thank you. Okay, I think we solved it. Okay, so I mean, of course, for me, there's much to do, but for now, let's copy this code, go to the XR talk show, so I can paste it, so you guys can play with it if you are learning Emacs Lisp. Okay, so create a new pre-tag. Wait, not we want Emacs Lisp. That's right. Paste it there. Show in browser. Go down. Fantastic. Switch back. Press 3 keys to syntax colored thing. Show in browser. And there we have the code. Oh God, what ugly code. Actually, it's not too bad. I mean, there it is. Okay, that's today's code. It will check at least one file. Then you can just make it check all directory, and you can add more. Yeah, basically we covered it. Thank you guys for watching. Fantastic for Subhajit for the donation. Thank you. Bye, guys. Yeah, bye, guys. Bye bye. Bye bye.